to point out I didn't actually show any example of a compositional scenario, so we can try one live and see what happens here. So this here's an example, a very simple example of a compositional scenario in Scenic. So this one is for the Webots robotics simulator, which I'll run in just a second. And so what it's doing is we are picking a region here, which is it's a rectangular region centered at 0, 0, 1. So like the origin and then go up 1 unit. And it's an 8 by 8 rectangle centered there. And we're creating a couple of classes of Webots objects here. This Webots object thing is defined in the Webots model. It's basically a subclass of the normal Scenic object class that has support for Webots objects. And the new thing that this is using is this Webots ad hoc property, which basically says this is an object which is not going to exist ahead of time inside the Webots world that I'm simulating. So we should just create it like dynamically, as compared to some other Webots scenarios where we're telling Scenic to take control of existing objects in the world. Not important, just that's what this is talking about. So it's basically saying, create this floor object, and it should not simulate physics. So it should not, the floor object should not fall down according to gravity. But this ball object, which is going to be a spheroid by default, should have physics. So actually, I think we might not have looked at the syntax for defining classes before in Scenic. But it looks a lot like the Python definition plus these property definitions like this, where this is saying the default value for the height property is 0.5.
It's in the text.
Oh, yeah. Oh, it's in there. Great. Okay, good. Thank you. All right. So then here's the part that we didn't talk about, the dynamic scenario syntax. I mean, I showed a very brief example, but here we're defining two scenarios. One is called height and range. And all this does is create a ball uniformly at random in this air region. So somewhere in that rectangle. The setup here, what this means is basically this scenario works just like ordinary Scenic code as if it was at the top level of a file. So all those examples you wrote where you're saying new car, new object, blah, 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 you can put any of that code inside the setup block of a compositional scenario like this, and it just interpreted the way that you're used to. The other thing you can do in a compositional scenario, though, is also have this compose block, which lets you combine other scenarios together. So in the main scenario, we're saying create this floor. And now in the compose block, we have an infinite loop where we're going to run this sub scenario item range for 10 seconds. Then this loop will iterate and it will run again. So the effect should be to spawn a new one of these balls every 10 seconds. So I want to try something with Webots. I think this is mentioned in documentation. I have to double check this, but you need to launch it from inside the virtual environment where you have Scenic installed, so then Webots knows how to find Scenic. So that's why I'm in the virtual environment where I have Scenic installed. I'm running the Webots, which on Mac you do like this, but different on the platform. So we'll fire up Webots. One thing that's a little bit different about the Webots interface, in case you want to use it, is unlike the Carla interface, where you start Carla separately and then you run Scenic separately and they talk to each other. For Webots, we actually need Webots to call Scenic. So everything's going to be launched from inside Webots. So I'll show that. Oh, it's open, but it's in the other screen. Okay, so here's Webots. So, oh, I already loaded this one, so it's starting automatically. There. Okay, so this actually just started running. You can see down here it says start a new simulation, starting simulation 1. Wait, did we get a termination criteria? Oh, 10 seconds.
No,
There's a second. Okay, there we go. So every 10 seconds of simulated time, we should get a new ball. And it's actually running slower than real time, which is surprising for such a simple simulation. Probably because I have Zoom running at the same time. So it's trying to do video encoding. Okay, there we go. There's another ball. So doing what you expect.
Well, actually, self of the floor.
They're starting in midair and they fall down. Yeah, so that's why we should see another one in just a second here. Because we're telling Scenic to create them one unit off the floor, and then physics is pulling them down. It's getting lower. Oh my goodness. Yeah. This is terrible. I'll just start it again from the beginning.
Can you do with an item rain? The name of the scenario.
Yeah.
Do item rain, comma item rain. Then it should have two balls all.
Yes, let's do it. Let's do it. So let me just show you here because this will actually lead into what we're going to talk about next. This is the code that's running in Webots to call Scenic. So the supervisor thing is a Webots concept for something that basically controls the simulation. And you see what it's doing here is it's importing Scenic and it's calling some Scenic APIs to compile the program you want to use and then generate a scene and then simulate. So this is the topic that we're going to discuss next. It's using this Python API. That's what's going on under the hood here. That's how Webots is calling out the Scenic. And so if I go back here, see, this is the path to the Scenic program that I want to run. So let's open that up again. Over here. Okay. So here I have that into the group doing just one of them for 10 seconds. Let's try doing two of them. So this is now a parallel composition of two copies of the item rain scenario, which you're going to run for 10 seconds. So this should create two balls at a time, if this works. There it was, but I didn't see it because we weren't zoomed out enough. Let's wait for the 10-second mark. It should create another two.
If you make boxes, it might be faster. I think we have very precise spheres in Scenic for Webots.
Oh, it could be. Well, we're almost at 10 seconds, so let's wait. There we go. So it works. Okay. While we're in Webots, I wanted to show you the Mars rover one, which some of you might have seen in the Colab notebook, because it's a lot more interesting looking than Webots. So I have that one here. It's in the examples folder in the repository too, if you want to fire it up in Webots. Just download Webots and open up this WPT file in our under examples Webots Mars. Okay, so here we've actually put in this model that Webots comes with of the Pathfinder or the Sojourner Mars rover. And we put in some pipes and rocks and this flag, which are just right now in kind of starting positions. And if I start this running, I've set this up to call out the Scenic and start generating some scenarios. So this one takes a little bit longer to generate. So we'll see what happens. The simulation can be incredibly slow, given how slow the other one is, but at least we'll see the initial condition. Okay, here we go. So you see you have this kind of irregular surface. We've got a couple of pipes here. There's a rock between the two pipes. So this scenario, we won't look at the code, but it's trying to create a bottleneck sort of situation where this rover is trying to drive towards the flag, but there's this bottleneck between two pipes with a rock in between. So this rover can fall over these rocks, but not over these pipes. This one, you can actually steer the robot. It's hard to see, but it is actually moving very slowly. The simulation is running at 1/4 speed right now, but you can actually press some buttons here to steer the robot, try driving around. Or I can press T here to tell Scenic to generate a new instance of this scenario. So I'll do that. Now Scenic is generating a new scene. Should be coming in a moment. There we go. So now we get a different configuration of the rocks and the pipes. So just to give you an idea. So let's explore these things.
You can show that looks like an internal visualizer too. Okay?
Yeah, sure. I think we might not have seen it in the notebooks. So if we run that same one, examples, Webots, Mars. I think this is a narrow goal one. We could see what it looks like in the visualizer. So this is an interesting example because it shows how you can do stuff like create irregular surfaces in Scenic. If you're interested in that kind of thing, come talk to us later. We can show you how this is done. The code is not too hard to understand, but basically we have like a fake kind of object representing a hill. And we are adding up, we're making a height map by adding together the heights of all these hills to create the geometry for the actual grounds here, which the real life is driving.